Hello, everyone. Welcome back to the bench. Today we've got something a little different. We've got an alarm clock. Now, this alarm clock I've probably had since 1999, 2000, something like that. So it's a good 25 years old. And as you can see, the screen has some weird things going on. It's been like this for maybe the last 10 years. It used to kind of twitch and do weird garbled displays on it, and now I've decided I'm going to finally unplug it and get it working again because I don't really like relying on a cell phone. I tend to hit snooze too often and sleep to the glorious ringtones that you can use. So I need something a little obnoxious like this to wake up in the morning again. So let's clean it up and open it up and see what's going on. I'm going to guess that it's 25 years of dried up capacitor. So we'll find out. So obviously the first thing I want to do here is clean it up because it's got a lot of dust on it. That tends to happen to things that have been sitting in the corner for 20 years. So let's give this a nice little Clorox wipe. Get all that schmegma off of there. Well, that was pretty easy. It's just a couple Phillips screws to get in, and here she is. You can see it's pretty simple design, very very late 90s looking. We've got some electrolytic capacitors. We've got a very basic AM FM radio circuit in here, small speaker, LCD display. And right off the bat, you see me point there, there's a ceramic capacitor with a big giant crack in it. And that is most likely our culprit. Let's get a little closer here. It's interesting. There's some glue up against this ribbon cable with this resistor here, which is probably factory to prevent it from melting the ribbon cable. But that particular glue likes to dry up and cause problems later on in life, anyways. So I don't think that's causing our problem right now. We'll keep looking around and see. There are some discolored resistors here. They've gotten heat over time. There's a lot of shmoo holding things together, but typical cheap stuff. So let's keep exploring. So as I'm just looking over, trying to see if there's anything obvious, there isn't really anything obvious. So the first thing I'm gonna do is just change out all the electrolytic capacitors, because something, once you hit the 20-year plus range, you know that your capacitors are either going to leak, and if they're not leaking, they're going to have a high ESR value, and it's going to cause something in the circuit to go bad. Um, in a clock circuit, I mean, you wouldn't really expect much. Maybe the display will go bad like it is, but something like that is more important in RF radio stuff. It's going to cause all sorts of or problems. So it's just a good habit with old electronics. You change the caps out because it's cheap and it's super easy to do, and it usually solves half, if not all, of the problems that you have. Now, if it doesn't solve problems, what we can do is look up that clock chip that's on the board, and we can get an example schematic of how it's supposed to be wired up, because there's no way I'm ever going to find a schematic for this to do troubleshooting. However, it is using the most basic of power circuits, AM, FM circuits, clock circuits, and we could go that route, searching for diagrams of just basic circuits and matching them, or using the chip part number on here and looking up a diagram. But first, let's pull all the caps. As you can see, I'm doing, I use a Sharpie. First, I find all the pins and I just note them with a Sharpie pen, because that really helps with the solder sucker, knowing where to go. And we'll pull them out, and just for fun, I'm going to test them with my ESR tester here, and we'll see if any of them are really low and bad, and we'll replace them just for fun with some cheap, crappy Amazon capacitors, because this is an alarm clock and I don't care too much about it. If this is a radio, I'd be putting in proper brand name ones, but let's do this just for fun. See that one there? Had a pretty good ESR, but the 145.6 microfarads is a little off, because that one was a 220. So, is it enough to cause problems? Probably not, but we'll change it anyways, and we'll keep going. Alright, so speed it up a little bit here, and I'll change all of these out, and then we'll come back after and test all of them as they're out. Now that I've got them all replaced, let's put this thing back together. I'd rather close it all up and turn it on, just because it's 120 volt right on the main board, which is not something I really want to have dangling around on the desk like this. Alright, so let's plug her in. That's funny. interesting to see that this is what you saw earlier on camera. It's showing me the problem it had earlier. In person, I'm seeing 12 o'clock. 12 o'clock. It says 2 o'clock right now. So that is what I see in person. Interesting. So that's what I see 205. The camera's struggling to pick it up, but that's interesting because the capacitor that was bad must be what's controlling the pulse width modulation or multiplexing of the display. See it change there? In person, I don't see that. So yeah, so that's it's the multiplexing of the LCD, because at any given time only one of these digits is on, and that's how it tricks the human eye in changing them or displaying them at different time intervals, so it appears to us like it's always on, but the camera at a different frame rate can pick these things up. So this is cool, but I'm glad that it's fixed. Okay, well, first one, open circuit. So we know that one was no good. Next one, 0.57 ohms, not bad for an ESR. The capacitance was out of whack though. 0.42, not bad. 357. That was a 330 microfarad. The first one was a 330 microfarad as well. Oh, 2 microfarads. That's way off. Had greater than 40 ohm resistance. So that one, garbage. Open circuit. So these things have just been sitting, cooking for 20 years. 2.3 ohms, that's too high. 150 microfarad on a 200 microfarad. 1.9, we're up there a little bit on the ESR. Again, these are not brand name caps, and they come from literally the worst time. The worst time was early 2000s for the bad cap era, and this just shows it. So thanks for watching, everybody. I know this is kind of a boring one. Tried to make it interesting using those the capacitance tool there just to kind of see what we had, but it goes to show there's a lot of easy repairs out there. Not everything's challenging, and it's a 25-year-old alarm clock, and to be honest, it's no different than any alarm clock you'd buy today. There's no point in going to the store and wasting $30 on a equivalent piece of garbage. So might as well keep it going and save something from going into the landfill. So please like and subscribe, comment below, let me know what you think, and we'll try and get some more interesting repairs coming in the next couple weeks.